Gabriel, Andrea, Fernando, Griselda, Sebastián, Dylan, Daniel, Oscar, Carlos, José Miguel, María José, Chelsea, Sofía, Sebastián, Bruno, Rodrigo, Joel, Pablo, Andrea, Marcelo, Giovanna, Paola, Sofía, Mariano, María Isabel, Rafael, Daniel, Guión, Fine. Okay, listen. While you write that, I already graded the quizzes. All grades are already in my text, you can check them later. But I don't have them right now with me because some people haven't done the quiz yet. So for those people, the quiz is going to be tomorrow at 3. Okay? Classroom 6205 tomorrow at 3. And on Wednesday, I'll give the quizzes back, all of the quizzes. Okay? But in general, you improved, so that's a good thing. The quiz was easy, but still, you improved.
Nice.
Yeah. In general, there was an improvement for this quiz. So I hope that the generation maintains that momentum. Discontinuity in the momentum, yeah. Not sure. Fine. Ready? Good. Ready? Ready? Okay, so the new topic is called implicit differentiation. This topic is going to be the next quiz. This Friday there is no quiz. It's going to be next Thursday. Okay? But this is going to be included in that quiz. Now, we're going to dedicate 3 days for this topic. It's not difficult per se, but, well, you'll see. Okay, so the idea for this topic is that so far we have seen explicit functions. What are explicit functions? Functions where the variable, the y, is isolated directly. For example, you have y equal to 3x squared plus sine of 2x. That's an explicit function because you have y equal to something. Okay? So, if I want, bless you, if I want to find the derivative of that, you just follow the rules directly. For example, derivative of y, y prime equal to 3x squared derivative will be what? 6x plus sine of 2x derivative 2 cosine of 2x generally. Okay? So what do I mean by directly? That is just directly y, y prime, 3x squared, 6x. This one is this. Okay? Just apply the rules like that. But what happens if the function is implicit in a relation? What do I mean by this? That the y is not isolated. It's inside an expression such as this one. Okay? One option will be to isolate the y and solve it. But this one, for example, will be to isolate, but this one will be complicated to isolate the y.
Yes.
So the idea is not to isolate before the derivative. No. The idea will be to find the derivative using implicit differentiation. It's a different process that uses chain rule mostly. Okay? And then we're going to get the y prime. Okay? So if you see something like this or like that, and the question is to find the y prime, you need to apply implicit differentiation. Okay? Not always we're going to tell you use implicit differentiation for that. So you need to see when to apply it, like in those cases. Good. Can I continue with an example? Yeah.
And if you don't tell us to use implicit differentiation, and it's like example, and we just isolate?
If you can, yeah. So in this case, you can isolate y, you have a square root as an answer. So, yeah, you can use it. But for this one, it's not recommended. Not recommended. Okay? Fine. Example, number 2. It says x squared plus y squared equal to 9. The thing about this is that we're going to find the derivatives the same way as we did, with a little exception in that we're going to treat the expression with the y as a composite function, that is something inside of another one. So the y itself, the y is not the x, the y is an independent function inside of another one. Okay? So it's a chain rule. Here, for example, x squared, derivative? 2x. Same as always, 2x. Plus y squared, derivative, we're going to use chain rule. We're going to find the derivative of the y directly and then the y squared. So y derivative will be not 1, y prime. Y prime is the same as that one. So you have the y prime is the derivative. So again, same situation. Y is y prime times the big one, y squared. Derivative y, just y. The chain rule is y derivative y prime, y squared to y equal to 0. Okay?
What about 9?
Okay. So from here to here, we apply the differentiation. Implicit. Okay? Is that clear?
Yes.
Yeah, it's just chain rule. Just chain rule. With the extra that the y is a function per se. So the y derivative is y prime, and then y squared becomes 2y, the big derivative. Because in this case, for example, the idea is that we're saying that the y is not just y itself, it's an implicit function in terms of x. Like this one, for example, this is the y in terms of x. But this one is inside of a relation, but it's still a function inside of a relation. But what about the x only? Well, same rules.
¿Y por qué no le pones que y sea 3 menos x? O sea, de que la isolate, de que y at the square is equal to 9 minus x squared?
Okay, you could isolate it, but it's not 3 minus x. It will be a square root.
Yeah, square root. So la square root sería 3 menos x.
Okay, wait, okay. Let me finish with this example and then we go to the other process. Right? Okay, in this one, this is not the answer yet, because the question is to find the y prime. That is, I need to leave the y prime alone. So what do? I need to isolate y prime. Y prime times 2y equal to, you pass that one, so it becomes minus 2x, and this pass dividing, so y prime equal to minus 2x over 2y, and can I simplify this? Yeah. So y prime equal to minus x over y, and that is the answer. That is the answer of this. Okay, we found the y prime.
Teacher, but that's not the same as if you had
We'll see. We'll see. Okay? Questions? No? Call it this example, but the idea is that on a derivative, when you have something with a y prime, because the chain rule, and find them. Yeah, I will. We'll do something like that. There. Yeah. Because the y is not x. If it was just x, yes, it's It's just 1. There is a reason for that, your question, Mariana. But using this notation is not the best way to do it. You need to use another notation, but I don't want to introduce you to that. Well, if you want to, I can do it. Introduce the notation.
Yes.
What?
No, teacher,
Okay, I'll leave it as an extra at the end of the class. Okay? But this is the important part. But there is a reason why it's not the same thing as this. Okay.
A ver con la notation, profe. Yo también quiero ver para el.
Wait, no, your question before, ahorita. You said that, why do I need to do this if I can just isolate the y? Okay, let's try. If I were to isolate the y from here, can I do it?
Yes.
Yeah. So, if I were to isolate the y from here, it will be y squared equal to 9 minus x squared. So, yours y equal to plus minus square root of 9 minus x squared, right? Can I cancel the square root with the 9 and with the x? No, I can't. No, it's a fraction. So, if I were to get a derivative from this directly, I can do it, but using chain rule. Will be y prime equal to, well, the plus minus, I'm just going to use the plus sign for right now, will be minus 2x times what? 1/2, 9 minus x squared to the minus 1/2, which becomes minus x over square root of 9 minus x squared, right?
So y would equal to
Which is the same thing. Why the same thing? The only difference is that if you observe this and this, it's the same thing. But the y is this. In this case, I left the y just like that, implicit. But in this one, I put the value of the y. But it's the same thing. Do you see it? Yeah. Which one is easier? This one. This one? Sure? The first. Okay. Yeah. 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 Always. Always. Again, there's a reason for that. Good. Questions?
No, so far.
Not so far? Good. What? The other what? Yes. Second derivative? Yeah, I wanted to apply derivative to this same process. But we want to find the first derivative only. Fine. Can I continue?
Yes, sure.
Okay. Now this one, it's a little more complicated. Here, for this one, 3xy, what is that? What operation is that?
multiplication.
It's a product, yes. I need to apply the product rule with the y. So, product rule. You have 3x and you have the y. 3x derivative, 3 times the second one, not derivative, plus 3x times derivative of the y. Y prime. Just y prime. This is just y. Equal to 5x squared derivative, 10x, no problem. Minus derivative of this, minus y prime, 6y squared. Okay? Again, for this one, the derivative is direct, no prime, it's direct. For this one is for y prime. For everything, 6y squared. Yeah? The what? Product rule. Remember? This is F, this is G, so derivative F prime G plus F G prime. So,
Y siempre va a ser un término solo.
in this one. This one, yeah. 3x derivative is 3 times y plus 3x times derivative of y prime. Second problem.
Profe, no.
Yes or no? Now what? Isolate, yeah, but now you have this y prime and this y prime, so what do I do?
Put the other y on the left and have the
Yes, very good. Terms with y prime in one side of the equation, terms without the y prime, other parts of the equation. So we leave 3x y prime plus y prime 6y squared equal to 10x minus 3y. Yeah? Now what? Factor, yeah. So y prime multiplies 3x plus 6y squared equal to 10x minus 3y. So finally, y prime equal to 10x minus 3y over 3x plus 6y squared. That's it. If you can simplify, you simplify, but in this case, you cannot simplify anything. You leave it like that. Questions?
No.
Profe, no, ¿qué cosa? ¿Cuándo usas cuándo le pones el signo?
When you find the derivative of something with y. For example, this one. 3x derivative is just 3. Now y prime. That's the second one. 3x times derivative of y prime. Direct. This one. 2y to the cube is y derivative y prime. 2y to the cube, 6y squared. Chain rule. So you're applying chain rule. Derivative of y, derivative of 2y to the cube.
O sea, como que dice, saco la y prima y luego hago la derivada normal.
Yeah. It's not as simple as that, but basically. Good. Questions? No? Okay. To summarize this, step number 1. Apply differentiation rules. Pass all terms with y prime to one side. Common factor and isolate y. Good. All of them. Good.
Factor in this 4 is isolated
¿Cómo dijiste? Sofía, ¿no te parece?
Visita, te recuerdo que estamos en vivo en YouTube.
Lo del pueblo se sube mañana antes de las
4.
¿Qué quieres en Implicit? Ah. Pero te voy a dar.
Ya veremos con los de
Ya veremos cuando se hagan
¿Qué? Ay, sí,
Okay. Let's try something a little more complicated, okay? Yeah. Yeah. Here you have 5x squared y to the cube minus sine 2x plus 3y equal to e to the y plus 4y to the cube. Okay? This one is a little more complicated because you have trigonometric and exponential in the way. Okay? Same process. We're going to apply the derivatives. First, product rule. Yeah. So 10x y to the cube plus 5x squared. I want to leave it indicated. Y prime times 3y squared. Okay? I repeat. Derivative, normal one. Plus normal derivative. Yeah? Okay, wait. This is F, this is G. This is F prime, this is G. This is F, and this is G prime. We're going to simplify. Just we're going to simplify. Minus. Here. Chain rule. This and this. So, derivative of this. 2 plus 3y prime. Okay, y. Put a parenthesis, okay? 2x derivative is 2, no problem. 3y is chain rule, the y prime and the 3. Correct?
Always chain rule.
For the y is always chain rule.
Yeah.
Yeah. In this case is y, derivative is y prime, and for 3y, derivative is 3. Times cosine of 2x plus 3y. Okay, it's chain rule, a big chain rule for this one. Derivative for this and for that. Equal to e to the y. Derivative y prime e to the y. Plus y prime 12y squared. Yes? Remember, every time you find a derivative with y, you need to put the y prime because of the chain rule. The y is not x, the y is a function. Like g of x, the same thing. Good. Yeah? Can I simplify this? Yeah. I want to simplify. 10xy to the cube plus, multiply the coefficients. 5 times 3, 15. X squared, y prime. Just move the variables, same situation. Here we have a binomial times the cosine. Get rid of that. By doing what? By multiplying. We're going to multiply this times this, this times this. So it's going to be minus 2 cosine of 2x plus 3y minus 3y prime cosine of 2x plus 3y. I just multiply. Straight the property. Why? Because you cannot isolate the y prime if it's inside of a binomial. So multiply. Equal to y prime into the y plus 12y squared y prime. Ah? Y minus y. No. That's a derivative. But you just find the y prime.
¿Por qué menos antes del 3?
¿Qué pasa en el
Y el menos 15 no también.
Tú eres la señora de Pajarina. La Pajarina. Llena de Pajarina. No, pero suena padre.
Questions so far? Okay, just by one person. Questions about this? Yeah. Yeah. What? The derivative of this? For this? That part? And the derivative for this have a number, right? So, in a parenthesis, put a parenthesis. Then I have this multiplying the cosine of this. So I multiply 2 times cosine, 2 cosine of this. Minus plus minus 3y prime times cosine, 3y prime cosine. Okay? But it's the same. Now what? All y primes in one side of the equation. Which side? It's up to you.
Left.
Right side? Let's try the Equal to y prime e to the y plus 12y squared y prime minus 15 x squared y prime and plus yeah. Now what?
Y prime equals to 2 cosine of 2x plus 3y minus 10xy to the 3 over, bueno, el orden lo tengo 15x squared times y squared minus 3 cosine of 2x plus 3y minus to the y minus 12y.
No, ya me acuerdo.
¿Qué le pasa?
Okay.
Factor común.
This is keeping one step. It's fine. So he already knows that this part, and that part are going to be dividing the other side of the equation. So he's keeping the factorization part, which is fine. But I'm good at it. No, still. 10xy to the cube minus 2 cosine 2x plus 3y equal to common factor. Y prime multiplies e to the y plus 12y squared minus 15
X squared, Y squared, plus 3 cosine, 2x plus 3y.
3 cosine of
2x plus 3y.
and then just divide. ¿Qué?
Sería más fácil pasar, o sea, quedaría de x a la 3 sobre.
Over e to the y plus 12y to the cube minus 15 x squared y squared plus 3 cosine of 2x plus 3. Okay? That's the answer. That's the answer.
Wow.
Two questions?
No, so far.
If I can divide, simplify, you need to do it. But in this part, no, you can't. Ajá.
Es que eso está multiplicando y todo eso lo podemos
Sí,
ayudamos.
la simplificación.
Yeah, what I mean by simplification is that, for example, you have everything in factor of 2. please. Okay, questions?
No.
También yo dibujé el pajarito con el email. Y ahí no le juego. ¿Por qué no juegas? Yo no sé. No tengas miedo. Ya le tengo miedo.
Okay. Can I continue? Okay, I admit this one is a little difficult. Something like this is not going to be this because it's very What?
¿Qué pasó? Ya no puedo.
Anyway,
Es que le gusta el pajarito. Profe, esta es la difícil de lo que vamos a hacer. Ya.
Dice que se le cayó en el aeropuerto también.
Okay, in this one, for example, the relation, the expression is easier, right? It's not as big as the last one. But the thing is that you also need to find the slope of tangent line at that point and the equation. Remember how to do it from the last part? Yes. So the idea is not to use the limit definition, not limits here. So the idea is that you have a derivative, you're going to find the derivative with the y prime, and then you're going to substitute the values in the derivative. Okay? Remember that this value is the value of x and this is the value of y.
Yes.
So let's find first the derivative. That's my relation. So derivative x squared derivative 2x plus 4y squared derivative and y equal to 0. Very good. Now isolate the y. This is simpler. Y prime equal y equal to minus 2x. So y prime equal to
Divided by
and simplify
Minus x
over
x or
4y. 4y. Okay, that's my derivative. Okay? Uh-huh. That's the equation. Yeah. But in this case, I need to find the slope first. Remember, that's my derivative. If I want to find the slope or tangent line, I need to just put the two values, plug them inside the derivative, and find the value. Okay?
También tenemos que poner la y la de abajo.
Yeah, of course. That one gives you both x and y.
mx.
So the slope m is going to be minus square root of 2 divided by 4 times minus 1 over square root of 2, right? So I just put the values, substitute them in the derivative, and find the value. Here, for example, minus divided by minus becomes plus, positive. Then you have square root of 2 divided by 4 times 1 is 4 over square root of 2, right? The idea is not to use calculator on this one, huh?
Entonces, 2 cuartos.
You can do that once at the denominator, so it becomes 2 over 4, which is 1/2. That's the slope.
Nice.
This time I want to give you the full point. You don't have to find the y or something like that. So you have the full point, just put the values and get the slope.
Perfect.
And the equation, remember the equation is y equal to mx plus b. I already have y and x, right? So let's find b. Y is minus 1 over square root of 2. M is 1/2 and x is square root of 2 plus b.
So you isolate.
You isolate. So basically minus 1 over square root of 2 equal to square root of 2 divided by 2 plus b. Isolate. Equal to b. Can I subtract those two?
No.
Yeah. Okay.
Yeah.
Could I change this? Could I change this into something easier to work with?
Yeah.
How?
You say
Rationalize.
rationalize.
Remember how? Yeah. We're multiplying by square root, so it becomes this. So it's easier. Why? Because they're the same. So minus square root 2 over 2 minus the same would be what?
-2 square root of 2 over 2.
Minus 2 times, yeah, what?
Porque es una simulación raíz de 2.
I rationalize. Multiply square root. And simplify into minus square root 2. Yeah? Because 2 over 2, they simplify. So the equation is going to be y equal to 1/2 x minus square root 2, which is the tangent line equation. All right?
Yeah.
Right.
The good thing about this is that you won't graph. Because the graphs are a little complicated. Well, not this particular one. This is not so much, but the other ones are a little more difficult. Yeah? Questions? No? Sure? We have time? Yeah, we have time for another one. Yeah? The x and the y and the derivative.
Queda alto. ¿Por qué Dalton?
Robert, a ver, ¿cómo fue la racionalizada ahí?
Por daltónico.
Yeah, so you transfer the denominator, so you multiply numerator and denominator by the same square root.
¿Qué color es ese?
So this
¿Sabes qué color que traigo?
Last example. Okay? Again, this one is a little trickier. We have a sign and a product, and the point is pi comma 0. Okay? If I want to find y prime for that one, what's my derivative? What do I do?
Y prime times
No.
No, it's a general.
General.
ala.
1 plus y prime times
Cosine.
cosine of x plus y. Why? Because it's general. Derivative of this and derivative of the sine. X plus y derivative is 1 plus y prime. X has a derivative, it's 1. It's not 0. And the sine derivative is cosine of the original argument, x plus y. Equal to
Power rule. No, the product one.
it's a product, yeah, it's a product.
Y prime times
Y
plus
plus
y
x
prime.
y prime. Derivative 1 times y plus x times the derivative of y is y prime. 1 by 1. Okay? Now, as I told you before, you have binomial times the cosine. What do? Multiply. So 1 times cosine is cosine plus y prime cosine of x plus y. Remember, I need to get rid of the parentheses. By the way, you need to put a parenthesis. If you just leave it like this, for example, I'll take 1/7. Because it's not just y prime times this, it's the whole argument, the derivative of the argument times the cos. Careful with that, please. Okay. Equal to y plus x y prime. Now what? Yeah. So this time to the left. Y prime cosine x plus y minus xy prime, right? I leave this one here and I pass this one to that side. Equal to y minus cosine of x plus y. Yeah? Factor y prime cosine of x plus y minus x equal to the rest. Pass divided. Over minus x. That's my derivative. Ah, okay, that's the question. Can I cancel the cosine? Because that's what we have subtraction. Yeah. If it was a single or you multiply y times cosine and cosine times x, then you can simplify. But in this case, no. Questions? Something like this could be in the exam. It's not as complicated as the previous one, but it's still a little challenging. Okay, find the slope. You have the point. X is pi, y is 0. So, will be 0 minus cosine of pi plus 0 over cosine of pi plus 0 minus pi. Yeah? Okay. Without the calculator. What will be the cosine of pi? No. It's minus 1. We're going to finish this. Cosine of pi is negative 1. Why? Because of the triangle, because of the unit circle, because of the hand, whatever. Cosine of pi is minus 1. Times minus is 1. Over cosine of pi is minus 1 minus pi. If you don't want to get this here, we can change it to be in the numerator instead. Cosine of pi is minus 1. Times the minus becomes plus. Minus 1 minus pi. And I just factor the minus, put it to the minus 1.
¿Y así queda, profe?
The slope. Huh? To make it easier, because in this case you have minus minus, so you could put like minus 1 plus 5. And put the minus instead in the numerator. It's easier that way. It's better that way. Okay, to finish this. Y equal to mx plus b. Y is what?
0 equals to 1 over minus 1
Uh-huh. Minus 1 over 1 plus 5 times 5
plus b.
plus b. So, 0 equal to minus 5 over 1 plus 5 plus b. So, b directly is going to be equal to positive. Why positive? Because I passed the whole term to the other side. So, it becomes positive. That's why I changed it. To make it easier to change this sign only.
Then y is equal to
So, the equation
1
is going to be y equal to minus 1 over 1 plus 5 x plus 5 over 1 plus 5. You can leave it like that, no decimals.
But it has to be fine,
Huh? No, not price, it's tiny line.
no?
Questions? Okay, tomorrow, free activity.